This is Laura Duncan from CSMS. Today we're going to be subtracting polynomials. Or adding polynomials, we push the tiles together and we group the like terms. And remember that we have to pull out the zero pairs. Remember that the zero pairs would add together and cancel each other out to be zero. So let's do an example of adding before we get back into subtracting. So please first note that it's adding and look for like terms. We have 2x squared plus x squared. Remember that there's an understood one here. So we add the coefficients to be 3x squared. 2 plus 1 is 3. Now what's like negative 3x? We have a positive 4x that is like. Well, the signs are different, so we subtract and keep the sign of the larger number. So that would be plus 1x, and there's an understood one there. And finally, we have negative 7. Remember to include the sign plus 1. So the signs are different, we subtract and keep the sign of the bigger number. Look back and make sure you have no more like terms, and that is the final answer. Now when we're subtracting, this is what you have to notice. We have a subtraction sign. And the subtraction sign says do the opposite to all the terms or tiles that follow it. Well, how do we do the opposite? We basically change the sign. So in terms of the tiles, basically the shapes change colors. If it was a white tile, it will change to a colored tile. If it was a colored tile, it will change to a white tile. So the changing of the tile is the extra step that makes subtraction different from addition. However, I want you to note the first polynomial stays the same. And that's because we're not taking the opposite of the first one, we're taking the opposite of the second polynomial. Let me show you what I mean. So this one will stay the same. This one will change to its opposite. So we're going to change this sign to an addition sign because we know how to add polynomials. However, for the second polynomial, we'll change that to its opposite. So let's redraw these. In the first polynomial, we have 3x squared plus 2x's minus 4, so draw 4 little tiles and fill them all in because they are the negative. However, for the second term, this is a negative x squared. We're going to change the color so it's a positive x squared. This is a negative x. We'll change it so that it's a positive x. It's the opposite. We have plus 2. We're going to change the color so that it's minus 2. Now that we have changed the color, then we can simply add. So notice we had 3x squareds plus 1x squared, 2x's plus 1x, and then a negative 4 for the units, and a negative 2 for the units. And then we can combine them all. So for the x squareds, we have 1, 2, 3, 4. So that would be 4x squared. We have 1, 2, 3 x's, so that's plus 3x. And we have 1, 2, 3, 4, 5, 6, but they are negative. So this would be our final answer after subtracting. So what we're really doing when we switch the colors of the tiles in the second polynomial is we're changing it to its opposite, which is what subtraction is. And then we're adding the opposite. So how can we do this without using the tiles? Well, we can simply change subtraction to addition by adding the opposite. We'll change the signs in the second polynomial to be the opposite and then add them together. Now, if you want to use the algebra tiles, the steps for subtraction is that you'll model the first polynomial with the algebra tiles. Those stay the same. Then model the second polynomial with algebra tiles. And thirdly, you'll flip the signs of the second polynomial. Then you can simply add them together. Let's practice some problems without using the algebra tiles. Now this is how you'll show your work. First of all, the first polynomial stays the same, so you don't have to rewrite it. One thing I want you to note is right here is a negative sign. So it may help your brain to think of this as a -1. It may help you to think of it as distributing a negative to each term inside the parentheses for the second polynomial. So this is an x squared, it would become -x squared. This is a positive 4x, it would become the opposite, -4x. Then we have -1, distribute that negative, a negative times a negative is a positive, so we'd end up with +1. Once you do that, you can combine them and add them normally. We have 2x squared minus x squared, and that would be an understood 1x squared. -3 minus 4x. The signs are the same, so you add and keep the sign of -7x. And then lastly, you have -7 plus 1. The signs are different, so you subtract and keep the sign of the larger number. Once you've added, if there's no more like terms, then that is your answer. On number 2, please be sure to rewrite the second polynomial, and I like to stack the like terms. So I have a negative understood 1 here. So this would now be a -12x squared. And I like to stack it under the other x squared. We have a -x, so the opposite would be plus x. We have a +5, so that would be -5. Now I can simply combine them as normal. So we have here two signs that are different. So we subtract and keep the sign of the larger number. So it's an understood 1x squared. Here we have 5x and an understood 1x. So we add the coefficients, and that would be 6x. Finally, we have 1 minus 5. Signs are different, so we subtract and keep the sign of the larger number. There are no more like terms, so that is our final answer. Be sure to rewrite the second polynomial. Try number 3 on your own. Please pause the video here. Please make sure that you have written down the second polynomial correctly after distributing that negative. And then when we combine the like terms, we're left with -2x squared plus 5x plus 4. And that's our final answer. Let's look at the last problem. We have a negative 1 here, so we're going to distribute that negative 1 to each term. So that would be negative 5a and then minus 1. We'll combine the like terms. 7a and negative 5a, signs are different, so we subtract and keep the sign of the larger number. And then we have 2 minus 1, that would be 1. And we keep the sign of the larger number. Since these are not like terms, 2a plus 1 is our final answer. The lesson is yours.